Hi, this is Chedong Huang from Seoul National University. Today I'm going to present our work titled by Exemplar-Based Open Panoptic Segmentation Network. This work is performed during my internship program at Adobe Research. We propose a new task called Open Panoptic Segmentation. In OpenSet setting, unknown classes appear during testing time. Panoptic segmentation is a joint task of semantic segmentation and instance segmentation. So it should segment semantic backgrounds and each instance. Therefore, in open panoptic segmentation, the model should find and segment not only known class, but also unknown class. There are several challenges in open panoptic segmentation. First, finding unknown instances is difficult, because unknown objects might have been labeled as background or some part of known classes during training. Second, labeling all objects for evaluation is almost impossible. Some objects are composed of their parts, and the definition of object varies by each person, and it is hard to give one concrete guidance. Finally, since ground truths are incomplete, PQ and RQ, which are the standard panoptic segmentation metrics, decrease as a model finds unlabeled unknown objects, and SQ cannot represent overall panoptic segmentation quality since it only considers true positives. We employ three straightforward assumptions for making OPS tractable. First, all unknown classes are thin class, because tough class is defined as regions or often ill-posed. Second, parts of known classes cannot be unknown classes. If tire exists by itself, it can be an unknown object, but tire in a car is not. Finally, unknown class objects only appear void regions, which are out of class or ambiguous regions in the training data. This is for preventing label conflict between known class and unknown class. Then let's talk about the baseline method. There is no method that directly tackles open panoptic segmentation. However, we can utilize class agnostic model. We use Panoptic FPN as our baseline, employing class agnostic regressor, class agnostic mask prediction head, and objective score from RPN. Unfortunately, class agnostic approach assumes unknown class has similar semantics with known ones. So it is hard to find the unknown class having different semantics. If we train these known classes, then if we test on these unknown classes, maybe the model cannot find the sea lion because it has different semantics. So we propose an exemplar-based open panoptic segmentation network called EOPSN. We first make over clusters for proposal features using k-image clustering, and among clusters, we select dense and high objective score clusters as an unknown class. Each elements are considered as exemplars of the unknown class. Then once a new image comes, we extract the proposal features again and compare the sampled exemplars features. If similarity between the proposals and exemplars is high enough, the proposer is considered as a new exemplar for the corresponding unknown class. We utilize MS COCO. We construct different splits with different ratio k of unknown classes among thin class. We remove annotations for unknown classes in the training dataset. We compare our EOPSN with the baseline. Our method achieves better performance on all splits without losing known class performance. Here is the qualitative results. The orange color presents unknown class. Our model can find stop sign in banana while the baseline cannot. Although keyword is one instance, EOPSN finds each key, which decreases PQ and RQ. In conclusion, we propose a novel task, open panoptic segmentation, and we also propose a novel framework for the task called EOPSN. However, several limitations still remain. EOPSN mainly focuses on recognition of seen unknown classes, and current evaluation metrics give a penalty with finding unlabeled instances. Thank you for listening.